Hi everyone, we are the third group, and now we will start our presentation. We will introduce our ESA project from this part. As you can see on the screen, there are 5 areas. First of all, let me introduce our group members. Although I'm not the team leader, there are 4 people in our group, respectively me, Ya Weitao, and Zihao Shen.
Hi, everybody.
And Zhu Taozhang.
Guys.
And Jingwan Li.
Hi.
Our group project mainly focus on how usable and effective a wearable assistive technology devices in assessing the visually impaired. Before I start, I want to give you the short definition of a visually impaired person. Visually impaired people. Not all visually impaired people are blind. Some visually impaired people have only amblyopia and they still can see something, but their vision is barrier. Visually impaired people's activities are limited by visual impairment. They can manifest in many ways, especially going out and about unfamiliar area. This is what we want to discuss. The more popular way to help the visually impaired is to let them use guide dogs or guide cabs. But at the same time, their shortcomings are also obvious. For the former, it costs a lot of money. For the latter, security need to be more considerate. So is there an available, safe, and effective way to help the visually impaired to move better? Our group brainstormed on this point of view and finally set the goal on wearable assistive devices. Okay, now let my team member Zihao tell you about our ideas and achievements.
Hi, I'm Bruce. Thank you, Jason. Now I will introduce how our innovation come into being. At the beginning of our project, we held some meeting to have some brainstorms together. Here are some important innovations we came up with. The first innovation we take into consideration is using acoustic feedback to guide visual impaired people. It uses some other methods to read the situation ahead and read it out loud to convey ahead information to users. The shortcoming of this way to give instructions is that it distracts users listening to environment and compromising their space awareness, which could result in security incidents. The second innovation we thought of is image recognition or laser beam. These technologies can scan surroundings environment and give suitable instructions. But how can they work to achieve such function? These technologies are using algorithms to process image taken from surroundings, reading information and give instructions. Sometimes they have to send message to remote data center and wait for instruction message. No doubt, this process will cause a fairly high delay, which could lead to unsafety. Next, we turn our eyes to haptic feedback. The first ideas come into our mind about haptic feedback is using Braille screen. We thought that most visual impaired people have Braille reading skills, so it would be easier to convey instructions using skills they already learned. When we found what a real Braille screen looked like, we thought it wouldn't be a perfect choice because it's so big and heavy. It would exhaust users carrying such heavy devices in hands, working on streets, and this would take their hands away from wide canes and guide dog. So this is another bad choice. we came into agreeing that haptic feedback is great because it has no delay and it will not affect users' listening. Here, later we found about the information about human skin and sensitivity. The most sensitive parts of human skin are head, hands, and feet. We thought that neither hand or head can be used to feel haptic feedback due to preceding research. So we turned our eyes to feet. Haptic feedback on feet is a great idea. If it's combined with GPS, internet, and a smartphone, it would be a perfect solution to help walking on street for visual impaired. Our final innovation is just like the image showed. It has three advantages. The first, users have no need to carry heavy devices on hand because this device is installed in users' shoes under their soles. Where could provide effective instructions and low distractions. The second, this device can be used with other methods, especially traditional guiding methods such as wide canes and guide dogs, which could make users even safer. The third, the device uses some highly developed technologies such as GPS and internet, which nearly wouldn't cause any delay. So this device is a lot safer than those using image processing or laser scannings. About how these technologies work together to achieve this goal, let me deliver our presentation to my teammate, Zhu Tao Zhang. Here you are.
Thanks for the Sense innovation part. Hello everyone, I'm Zhu Tao Zhang, and now I'm going to introduce you the principal part. That's page. As is shown in this picture on the PowerPoint, here is a brief introduction for the principle of our project, which includes two parts, a smartphone and a wearable on-show tactile display. The reason for using a smartphone is mainly due to the possibility of installing its GPS sensor, which is also often inserted on a smartphone nowadays, and its internet connectivity or portable computer capabilities. The purpose of using an on-show tactile display is mainly because tactile feedback, as mentioned by my team member Zihao Shen before, is preferred over the modality to avoid distractions from the environment sound and to ensure hand-free interaction, allowing users to hold and manipulate the parameters and other objects like a guide dog or guide sticks. So, in the next page of the PowerPoint, as we can see in the pages, on the left side, we can see there is a prototype of our project and the tactile sensor part of the human feet. And as you can see, the four green dots on the red shore is four vibrating actors, which is augmented in a certain order to better guide the user, which is also mentioned by my team members Hashan before. It is arranged in a certain way to better suit the human tactiles and on the gray box or next to the smartphone is the embedded systems, which will be attached to the ankle of the user. Such model transforms the instructions to actual commands and sets the tactile display accordingly. In sum, the user feels vibrates in the foot sole, pointing out the direction to follow. And for the red picture, it is a brief introduction of the guidance system of our project, which is augmented GPS. GPS system specially designed to reduce errors in the use of our customers in the daily life. And in experiment proves that users can be guided in acceptable accuracy, which will be detailedly discussed by my team member Jinwan Li. Let's welcome Jinwan Li for summary and the conclusion part.
Okay, thank you, Zhu Tao. Well, my team members have already covered the background, innovation, and the core technology of our research. Now, let me give a brief overview of the process and data for the product mentioned earlier. Now, let's take a look at the two pictures above. These are schematic diagrams of the experimental process which designed by Ricardo. We can see this experiment required both an experimental group and a control group. Two blind adult males, aged 34 and 38, were chosen to participate in the experiment. And two rows were set up with walking distance of 280 meters and 600 meters. Now, let's take a look at the data obtained from these experiments. We can see the two pictures below show scatter plots of the position arrows of the 8 GPS coordinate sets recorded during the navigation tasks. And the experimental data indicates that 95% of 8 GPS coordinates fall within an accuracy range of 0.9 to 2 meters. All right, now let me wrap up today's presentation with a short summary. Firstly, Yahweh introduced the background of our research, which include defining visually impaired individuals, the difficulties they faced, and our project and potential means of assistance. Then Zihao presented the innovation of our research, which including the limitations of exciting methods for assisting blind people in walking, and the benefits of using habitat feedback on the feet. Next, Zhu Tao explained the core technology of our research product, which includes two main components, a smartphone and a wearable tactile display that is attached to the shoes. And I have already presented the experimental data and conclude the entire presentation. Okay, that's all we have for today's presentations. If you guys have any questions, please feel free to ask us. Thank you.
我给大家。